are basically Rhinex files from one station covering the whole day, 24 hours, but with 1 second data rate. So basically, this is when we do the analysis of data. We always try to estimate, we analyze all signals which are received or tracked by the receiver during one day. Because normally, the constellation of satellites repeats approximately every 24 hours, which means that the other day would most probably give the same result or very similar result as the day before. So when you do the analysis of data, one day is typically enough. And during that one day, thank you, we prefer to analyze all data that are tracked by the receiver. So the receiver is tracking and logging with the 1 second data rate. That's why preferably we analyze data with 1 second rate as well. But especially here, as I have seen how long it takes just to install the software, then these Rhinex files. Yeah, but I know that this is just the PC, but the files are large. So if you unzip the files, then you will see that the size of files will be about 700 megabytes. So quite really large, I would say. Or any of these. So look. So if you unzip those files, normally you will, yeah, this, if you unzip this file that I gave you or you copy it, you will have 5 files. These are the Rhinex files, and the observation file, you see the size, for example, for Queque is 717, so it's really large file, and we need to import all these files into Spider QC. You have which station? Queque. So you should see something like this after you unzip them. Yeah, you see the same. If you open it, you see 5 files. And you can, but something is wrong. The size is too small. Can you go back? You didn't copy. It's not fully copied the file, is it? I think it's wrong. Did I give you wrong? But so the original size of files should be about 202. These zip files, 202. Yeah, this is the right file. Come and check. Yeah, sorry, man. Maybe I made a mistake. I made some kind of strange mix because it looks like so. Okay, sorry for that. Let's. So this file is so GSU. You have GSU, Cuthbert. Okay, so this one is fine. Now, Queque is incorrect. Carol. All right. Sorry, what's the size again? Sorry. Megabytes is wrong. Well, okay, it's also wrong. I'm wondering. Okay, what I did. Yeah, I confused some files. So sorry. Mm. Mm. Okay, I believe we are going to do it in a different way because just to... Sorry, what is the name of the site you have? What is the name of the site that you have? Volkova. And you had, sorry, you had sent me.
But the difference is I think above you. They don't want to hear about him. Let me know the secret between the two of us.
Yeah, the same name as before, but the zip file, yeah.
There's 198.
Yeah, it doesn't matter what it says, just the name is important, so click that.
hanzi ngasiya zvino zvino bozi yakandiri nanatoneta bozi munhu but juicy kuti inoenda kuti ndinoteerera ukanza iwo chivunga manje ukabuya kwaiziya kuti pane mudhara asingade kudzikana akaenda kutanga kuti kuti Imagine munhu akatamba like an ATM andile onzi izo zita kuita zvasoja lapha zviko zvaurisiitira.
All right. So try to unzip the files, the large files, and then we'll try to import them, and then we'll see if we can actually continue. Yeah, I'm gonna show you. I'm just waiting for all the others to.
Basically, I need time. Anambokuudza ishe kuti wakakomotokaziwa nditaura kuti izvo mabasa kutomboti nditori neidao tarisa vanhu kuti mange muri nesi wobvazvokunzi ndiwe wato ini ndo vandasara kana pane vanhu vanokunisa imagine how the only way you don't know how to transfer is that in the center of
This is what I say. One minute. Murume manje chake kungobuda
manager mari
nekuspenda nekutuma nezviro zvavanongazi murume akumbaenda mumba tiri kungofona kusvika padheni munhu uye akararama uda kumubikira
utanga wambogara
kuti wabika kutoedza mangwana odzidzo dzakamuka dziti handisi kuenda So, did you manage all to copy and unzip the files?
Yes.
But the setup changes.
Yeah.
But
Okay. Now, let's try to import it into. So if you open Spider QC, then we are going to import all those files into the memory of the software, and you can do it via this file and open, and we are starting with this GPS navigation file. The same functionality you can find on the toolbar, so you can only use these icons here. So it doesn't matter if you go through the file and open GPS navigation file, or you just press this button. It is exactly the same functionality. Then here you need to navigate to your to your Rhinex file. Where is it? In Genesis Rhinex. This is, I'm on the server, so you will have obviously different different structure, and navigate to this end. Just a second. So navigate first to this N file. So to this N. So you will not have station Zingsta, you will have your Kwekwe, I don't know what you have, and press open. It will import the navigation file for GPS. This should be fast. As soon as you open this GPS navigation file, all these other options to import the GLONASS navigation, Galileo, and Beidou will become activated. Also here in this file menu, GPS, GLONASS, Galileo. So you go step by step. You will import the GLONASS navigation file. So the software remembers the last folder, so it will automatically open the same folder. This is this G file. Then you will open the Galileo navigation file, and the last navigation file will be this from Beidou. And then you will open the observation file, this O file, and this. So you will see here information which file was imported. So you see the last imported file after the import. So this is the N file, this is GPS navigation. Now we go to GLONASS navigation. So in total you should import 4 files. GPS navigation. Okay. Here you see the problem. So even if you have a fast computer, it will take a while, maybe 30 seconds to import the file. No, we don't have. Yes, let's select observation and press OK. And then you will see here. It's not. In the lower right bottom, you see a progress bar. So if I select this O file, then you will see a progress bar here. But this was a small file. Normally you are trying to. Yeah, it will stop. But after stop, yeah. So here, you can already see that also. Yes, so this is the glass. And press open. Then you go to Galileo navigation. Yeah.
Maybe.
And you wait until you see that observation values. Actually, it's funny. It looks like the installation took ages, but then when you're trying to import the file, it seems it is not that terrible. We don't know. Nobody knows. Because we should have. Can you resize it? No. Yeah, like that. Okay. Solution file imported. Normally, you should see that file summary. It tells you 86,400 epochs were imported.
So
It is completed. So it can. Somehow on some computers is. Can you read it? You can resize it. No. Perfect. Actually, all right. Okay, it's actually better than I expected when I saw how took it long. Yes, it's quite a lot of observations. So now let's see this. How do I do this? First of all, you can make a very basic quick quality check, and so this is some kind of quick scan of the Rhinex file with some most important, I would say, quality indicators. This can be done manually, but this will also be done in this automatic way. So the SpiderQC will do this also for all your incoming files from the site server. So if you select File and Quality Check, and just select your file, the Rhinex file. Yeah, the observation one. So Rhinex observation, this one. So this is mine for Chimani Money. If you press Open, then once again you will see this progress bar. It will do the scan of the file and it will compute some. Doesn't matter. We'll need to do this again. If you didn't do it yet, then don't start the quality check now, because we have to make some settings first. I forgot. Okay, I will kill my SpiderQC because it's just to save time. So before we actually do the quality check, we need to configure SpiderQC with some important settings, and I'm going to show you where you can do it first. So in your SpiderQC, in the main menu, finished already or not yet? Yeah, it's finished, so you don't need to fill it. But we just need to make it. You just need to change. Yes, quite normal. Because first of all, you need to change here in edit settings some parameters. So please, whatever you see right now at on your screen, so most probably your Spider QCS finished the quality analysis, but with wrong settings. So first of all, you need to go to edit and settings. And here we need to make some configurations. So quality testing and processing, this is the very first section, this branch tree. And normally here, we have elevation mask. I don't know what you have. Per default, maybe 10 or 15. Yes, so you should change it to 5, because 5 is exactly the same setting that you have on the receivers. So the receivers are configured to track satellites above 5 degrees elevation mass. So we are going to do edit settings. You go to edit settings here.
It's like in digital print. Muda mzinamu. Muda mzinamu. Kemba muzona pamoja ndamo.
Was it industry? Yes, not just that. Edit settings. So here we change the elevation mask to 5 degrees, just to be compliant with the same setting that we have on the receiver. Minimum number of satellites, we keep 5, so it will report if you have less than 5 satellites. Minimum SNR set to 0, if not, and report data gaps one epoch. So basically, the receiver will check if since we are using a Rhinex, which is created from downloaded MDB file, we should not be missing any epochs here. And for missing satellites, this is correct. So on this first page, you should keep these settings here. And when you open this branch tree for cycle slip detection, we keep the default settings, the same for multipass. For quality testing, in this section, set, well, I don't know what you see here. Normally we test against 95 degrees, this 95%, but it might be too optimistic in your case, but let's keep it just for fun. Set all parameters to 95%, which means that the system, SpiderQC will warn you if you have less than 95% of data in the Rhinex file. And please set this one off or uncheck this, ignore orbit related problems, because then we would have a lot of messages due to GLONASS. 4666. Other, ignore orbit related options. So your settings should look like this.
What about QZS?
You don't have QZSS data. You don't need to worry about it because there is. Yeah, this is used only for automatic processing, this first line. So this will not affect your manual manual data analysis. So, and required observation times, you keep the same. And in satellite status, please remove satellites R6 and R10 and R23. You see, in the satellite status, you can remove some satellites from data analysis. And please remove R6, R10, and R23, because currently these satellites do not transmit on L2. So once again, this would R6, R10, R23. The satellite. And here, not the G. Remember that we are talking about R satellites. These are the Russian satellites. So R6, R10, and R23.
What is their effect? What is their effect?
The effect is that these satellites only transmit on L1 frequency. Normally, they are set as healthy, which means that the SpiderQC expects observation on 2 frequencies. So it will always consider this second frequency as missing data. And it will basically affect the whole, basically, quality estimation for GLONASS as a complete satellite system. So, yes, R6, R10, and R23. That's all that we need to do here, and we press OK. And now, well, we can try to do what we did before. So we go to File, Quality Check, or you can even press this one, QC. This is the same button, Quality Check. Select your file and press Open. Yes, observation file. It will automatically, basically, check the navigation files, and so you will see, depending on how fast your computer is, it will take a while. The file is quite large, so then you see some results. Depending on what Linux file you have, you can see what pass, such as in this case. So here, Yeah, but I saw the results now. Can you resize this window? Yeah. It also passed. So this was the previous. Okay. Okay. Sorry, I thought it was already after we changed it. So
Can't see anything.
you can see. Change your glasses.
It's finished.
Can you resize? Sorry. Yeah. And you can now, if you resize it back, normally it keeps. There is some. Yeah. I don't really understand why. You can even. So after we change the settings, and funny, your computers are faster than mine, but mine is 5 years old. Yeah, I'm waiting for a new laptop. I will not be able to, unfortunately, install something. Windows. No, that all of somewhere else. Windows. So all of you have results for me. It's very sad. But can you go to the top? Yes. So here we see quality testing failed. Which station is that? It's
Quality testing for quick fast.
yeah, so that's a good sign. Now I would like to show you some. Come on, what's wrong here? Yeah, it can happen that time. Well, then it can run into this. Okay, I have a problem because my CPU runs at 100%, so something is killing my PC. What is it? Firefox. Ah, it's this streaming. Okay. Um. It looks like we have something. All right, finally. All right. So you will see more or less this type of information. If you see, okay, first of all, you see what you have imported into the Spider QC, and then you see quality testing. This is kind of a general indication of the quality of the Rhinex file. If it says fail, then it means there is a problem. If it says pass, more or less, you can be happy because all these quality testing thresholds that we have set, such as the 95%, and there are others, all of them basically passed, and the Rhinex file is okay. So for Chimani, you see the station details. So all this information is read from the header of the Rhinex file up to here. Then what Spider QC does, it actually computes the position from the Rhinex file and compares this position with the position in the header of the Rhinex and gives you the difference. So 6 meters. So this is what also tells you something about how accurate this so-called absolute positioning is. So if you don't have any correction data, you cannot expect better than, as I said, 3 to 15 meters. So 6 meters is fine. If you would have a difference of up to 1,000 meters or something like that, or even 100 meters, that indicates that you have a wrong position here in the header of the RINEX file. The observations which are in the RINEX file do not fit with the coordinates which are in the header, which means you have some kind of mismatch somewhere. So normally you should also see very, very small values here. I would say more or less the same thing as here. Then SpiderQC gives you the session summary, time of the first observation, time of the last observation, the session length. You should see 24 hours. So we have the full basically observation set for one constellation, not for the full constellation of all satellite systems. This is the so-called GPS week. Observation interval, you should see 1 second, beep second. This is this information read once again from the navigation files. If you have something different than 18 seconds, this means that the time which is displayed in the RINEX file is not correct because it doesn't apply the leap second correction properly. And then you see some kind of general information about how many satellites with observation you have and how many satellites. So in total, you have observed 116 satellites over 24 hours, which is quite a lot. Then you see satellite with navigation, GPS orbits, GLONASS orbits, etc., etc. Then you have satellite with observation and without observation. So these satellites, for some reason, were not tracked. Either these were in this unhealthy status or there was some other problem. So this is some kind of general overview, and then we have another section called quality testing, and here we have more detailed view or different parameters that have been tested. What is important that we have some kind of general tests. First of all, epochs with data. So how many data, how many epochs you actually have in the RINEX file. All these RINEX files are created from downloaded MDB files, so all of you should see the value 100%. Because we had no gaps in the, normally we have no gaps created by the communication. The receiver was tracking properly, there was no antenna disconnection, etc., etc. This means that you should not have any other value than this. If you have something lower than this, it means you have a problem with tracking. So the receiver cannot log data on the SD card, or the SD card is corrupt, or there is some reason why you could not actually collect this data. Then it checks for the file format, receiver clock, and some other quality indicators. Everything passed well. Then you are more or less happy with the general test, and then you go to specific tests for each satellite system. So GPS, specific test, cycle slips. So this is what I mentioned yesterday. Cycle slip is this interruption of tracking, which is negative for any kind of positioning service, so real-time, post-process, anything. So normally you should have cycle slips under certain thresholds, which are set by the software. And as you can see here, for Chimani, the GPS specific test, they failed. In total, I had 9,100 cycle slips. The threshold, so this critical value is 3,048. So it is necessary to say that these values are computed dynamically based on how many observations are in the RINEX file. So for your sites, you might have different thresholds. But in any case, for all of you, when you have pass, you can actually how to say zoom. So you can see that you have completely different values. Your threshold is 3,500. This is because your RINEX file contains more observation. So this is testing against, I think, 95% value. So as I said, these values are computed dynamically based on the amount of data that you have in a RINEX file. Anyhow, if you have an indication that the cycle slips value are too high, that means that you have a lot of interruptions of tracking. So this could be due to obstructions, or this can be also due to some interference. So these are the two main sources for cycle slips. Then multipath, this is another important parameter. So these are the so-called reflected signals. So normally what you want from your reference stations to track signals directly transmitted from the satellite. You don't want to have any reflections, because every reflection generates some kind of distortion of data. So multipath is another important value, and multipath is estimated on each frequency separately. So that's why we have three values here: multipath on L1 frequency, L2, and L5. So you see the real value and you see the threshold. So the threshold for all of you should be set to 0.5 meter. So I can see here that this station doesn't have problems with reflected signals, so doesn't seem to be set in the reflective area. But as I said, we have too many cycle slips. And data completeness, as you can also see here, the threshold is set to 95%, and I have only 79% of data. So this already indicates that this is not just some kind of obstructions, but we have something that really limits the amount of data which is tracked by the receiver. So most probably there are some solid obstructions, maybe I don't know, something, buildings, mountains, who knows. But this is already an indication that this site has some problem. When we have a look at the similar quality indicators for GLONASS, you can see that the cycle slips did not reach the critical value, but it's very close. We have 2,100 cycle slips, and the critical value is 2,500. So multipath more or less fine, but you can see that the data completeness, once again, more or less the same percentage, only 82% of data is recorded, once again indicating some kind of huge obstructions. When we have a look at the Galileo, similar results, value 84% of data, and at Beidou 85. So if these values are more or less similar, this indicates this is not a satellite system specific problem. This is really a generic problem for the station. So how do you see it in your result? So in your case, I just need to see the okay. So 98%. So if you have values, the data completeness 96, 98% is a very good start. Basically no obstruction. So we have also similar values. This is station is it? Okay. So we also this quality testing. So even for GPS, we have only 96% of data. So this is not so great. 88% for other the activated satellites is R6, R4, R6. Yeah. 95 for Galileo. They do 80, 94. So this side is significantly better than mine, but has some issues. So GSU 97, so 96 looks very good. 99%, 97. So this side is not so good because I see that this data completeness was close to 95, 96% in some cases. So still okay, but in fact, everything that is in red in the report indicates some kind of problem. All right, this is good. 96, 93. I didn't change the threshold here. Yeah, we said that we will set everything to 95%. 97, 95. But generally speaking, this. Okay. So, all right. 97. So we have my side is really affected. You can see that. Then we have another one which is not so good. It's Gokwe, and then that one was good. GSU yours was good, and here we have some, and also Zuka had some low data completeness. So these sites there is an indication that there is something around, not as bad as Jimani Mani and not as bad as Goku. So we have some additional information about tracking. So these values give you some information about theoretical values, how many satellites could have been tracked, possible observation about 0 degrees, about 5 degrees. These are not so interesting values. Here we have the geometry of the satellite. So all of you should have values at least similar to what I see here or lower, because this side has some huge obstruction, so the satellite geometry could not be as good as yours. So normally you should have values between 1 and 2, I would say. If you scroll down and go to this section, satellite geometry. So satellite geometry, if you remember the first training session we discussed about satellite. Yeah, this is exactly what I would expect. So from 1 to 2, 2.5 for PDOP. This indicates the deployment of satellites. Here we go. All right. Yes. Okay. Despite the fact that there's some fail tests, the geometry is good. So you will most probably have different problems. So you don't have huge abstraction because the geometry of the satellite is fine. Yes, this is very good. So if you have these high values, which means that you really have something obstructing the view to the satellite, then the geometry is worse. If you have basically good geometry, which means there are no obstructions, solid obstructions, but if you have some other tests that fail, for example, like you, then there must be another reason for that. So it could be, we will see later on. What you see here, gaps. So normally, if you have data gaps in Rhinex files created from MDB source, then you have a problem with SD card. Because normally you should not have any data gap. So even if there is some interference, the epoch will be stored, but will be no, there will be no data, or there will be some data which will be corrupt. But you should never have any gaps in Rhinex files created from data streams. This parameter can be actually used very well to see how many gaps you get from the raw data streaming. So if you analyze the Rhinex file created from the raw data stream, then you will have a list of gaps, and you can really see how many minutes or how many seconds or many hours of data you lost due to communication. So these parameter data gaps can be used for analysis of your communication lines, actually. So if you want to prove, if you want to tell your TO1 how much data you're losing and where are the gaps, then you analyze and use this spider QC analysis of Rhinex files created from raw data streams, and these gaps are the gaps related to the communication. So that's, yeah, because normally you should have 0, at least in this case, because this Rhinex file is created from downloaded MDB. So the MDB is created on the receiver, then we use these files from the receiver from the SD card. But you can create the same Rhinex file from the data stream. And then all the gaps that you have in the communication would be shown here. So you could use it as a proof of, as a complaint that how much data you're actually losing because of the failing communication. And here we have an overview of satellites that have been tracked above 5 degrees elevation. And then you will see here information about how many minutes the receiver was tracking the satellites. So this is kind of, yeah, a nice overview, but not so interesting. You can see we have this information for all satellites, which we tracked. So it was more than 100 satellites. If you have a section about the receiver, and normally you should have values here related to the 0. So this is the clock of on the receiver. So clock of the receiver is very important. It should not have a very high fluctuation. If the receiver has a clock which fluctuates a lot, you will see some values here, and that would indicate a problem of the hardware. And so normally you should have values here close to zeros, as shown here. And then we have quality indicators by satellite systems. So here you can see number of observation about 0 degrees from different satellite systems. So this is in total, and this is a theoretical value, obviously, because this is above 0. And then you have tracking over elevation mask 5 degrees. So this is what you have. And here I can see the theoretical value. So this is what in theory I should get. And this is the percentage I have. So you can see I'm losing a lot of data, up to 50% of data from all satellite systems from the station. And so this, once again, you should have different values here. You should have values about 95%. Yeah. Tracking information, yes. What does it say? Yes, number of observations about 0 elevation mass. So this is a theoretical value of all possible satellites. In total, you could have 3,492,000, I don't know, observations. And these are the partial portions for GPS background. Then we go below to this above 5 elevation mask tracking. And then you have a number of observations, you have number of possible observations. And also a number of complete observations. And based on that, you get this final percentage. We also have values which are a bit lower than normal, especially for GLONASS, but not as bad as mine. So as you can see that I'm seeing values about 83%, 80 or even 79. This indicates really a huge loss of data. So all of you will have something about 95 or more or less like that. Then we have, this is not so interesting, the cycle slips. Once again, number of cycle slips about 5 degrees elevation mask. I have huge values. You should have, all of you should have lower values. And once again, this is the indication of interruptions of tracking. So the higher value, the lower values you have here, the better. And basically, we have just some statistical overview of how much these cycle slips affect the observations. Loss of lock indicator. This is also related to different values, different satellite systems and different frequencies. We have section for multipath. Once again, these are the reflected signals. Normally, you shouldn't have values higher than 0.5 meter. If you have something which is more than 0.5 meter, then it really indicates there is some sort of reflection. And then we have some kind of extended quality information. So this is information about tracking. These are all the different signals that the satellites actually transmit on code, phase, SNR, and Doppler. So these are all the signals that the receiver gets during these measurements, GNSS measurements, so code measurements, phase measurements, SNR values, Doppler. Once again, you can see the percentage of how many basically observations the receiver was able to get. Ideally, you should have 100% everywhere, but obviously this will never happen. So you should have something close to 100%. Or for some special signals which are not implemented on all satellites, you will see some lower values. But generally speaking, these main signals like L1C, L1P, L2C, L2P, you should have values which are very close to 100%. Then you see tracking by satellites, and here in my case, I see a lot of red values. This is basically because the satellite could not track all basically data that it in theory should. So you can see by satellite the elevation, the minimum elevation, the maximum elevation of the satellite. And if I see something red, this basically means that this satellite was only able to track 93% of all theoretical observations. Also, you can see the number of cycle slips. So here you can already see that if the satellite was flying low, it lost a lot of data. So this is a common, in my case, as soon, well, but I have actually this problem for all stations, for all satellites here, because all of them, yeah, were rising. Yes.